All right. Hello, and thank you so much for joining us today for this week's session of the Parks Weekly webinar series. My name is Amy Price, and I'm the Outreach Coordinator here at Parks College. I'm joined today virtually by Dr. Chris Carroll and Kelsey Musa, who will be showing us around the Structural Engineering Lab. We're so excited to have you joining us today from wherever you might be. Thanks for taking the time to virtually visit and learn more about the Civil Engineering program at St. Louis University. In total, Parks College has programs available in aerospace, biomedical, civil, computer, electrical, and mechanical engineering, as well as flight science and aviation management and engineering physics. We hope that today you'll see something that piques your interest. Before we start, I wanted to give you an idea of how the webinar will flow. I'll soon introduce Dr. Carroll, who will be showing you around the lab space and sharing information about civil engineering. He will then introduce Parks student Kelsey, who will share her experience of being a civil engineering student with you. Finally, we will conclude with time for questions and answers. Throughout the webinar, please submit any questions you may have to the Q&A feature at the bottom of your screen if you're using Zoom, or if you're on Facebook, you can submit questions to the comment section, and we'll do our best to answer as many questions as possible during the last 5 to 10 minutes of our session. Throughout this webinar, you don't need to worry about turning off your mic or camera. You can hear and see our presenters throughout the webinar, but we cannot hear or see you. Finally, if you have any technical difficulties during the webinar, please email parksevents@slu.edu, and we'll do our best to address issues that may arise. The session will be recorded and posted to our YouTube page by early next week, and you'll receive an email with that link when it becomes available. And now, with all of that housekeeping out of the way, I am very happy to introduce Dr. Carroll and the Structural Engineering Lab. Dr. Carroll, I will turn it over to you now.
All right, good morning. I hope everyone's doing all right. So I am going to give you a quick tour of the structures lab here. And so to start off with, I wanted to just tell you a little bit about civil engineering. So civil engineering is one of the broadest disciplines within all of engineering. And so we have 6 subdisciplines. And so that includes construction engineering, environmental engineering, geotechnical engineering, structural engineering, water resources engineering, and transportation engineering. And I'm going to tell you a little bit about structures today. And so structural engineering is focused on everything to do with buildings and bridges, but we go a little bit beyond that. One thing that we like to do in class here at SLU is really focus on hands-on learning opportunities. And a lot of programs say that, but we really kind of take that to another level here at SLU. And I'm going to show you around a little bit to show you what we mean by that. And so let me start off here by giving you a little tour of the lab. So our lab is actually funded by the National Science Foundation, along with some other sponsors, which are on the wall here. So you can see some of these. And our lab is pretty good size. So it's about 45 feet in length. So from the garage door here behind me to the other end of the lab is about 45 feet. And then we're about 35 feet wide, and we are really tall. And so you can see the crane here. So we're actually pretty tall as well, so we're about 35 feet there. And so what we do is we use this space for research, but we also use this space for educational experiences for the undergraduate students. And so rather than just showing videos in class, we will actually bring students in here and do live testing during class. So for example, you can see here in the floor, we've got some concrete beam. This beam is 19 feet long. And it's a sample of one that we tested last spring as part of class. These are what's left over from those beams. Once we test them, they do completely fail. And then we have to cut them up and dispose of those beams afterwards. But instead of just showing a video, it makes a much more of a bigger impact on students when they actually get to see that happen firsthand. The way that we test those is here in this testing system. And so I'm going to try to zoom out as much as possible here. And so we have a testing system that consists of what we call these big concrete Legos, and they're held together by some large steel rods. And then we have a testing system up here. And so the beam that you can see running right across here is one of our test specimens for steel design. And so what we do is we're actually going to pull down on that beam right here using some hydraulics. This particular beam we can pull down with about 20,000 pounds with that hydraulic actuator. We have some larger actuators that can go up to 100,000 pounds. So one of the concrete beams we did held almost 80,000 pounds before it broke in class. So we like to do things big. We like to make sure that you get to see that happening. And then just to give you a little more tour of the lab here, we had a little bit of fun with our wall here. And so you can see the SLU civil engineering, and then it's also coated with all of the equations, or several of the equations at least, that you would actually learn about during your time in our program with regard to structural engineering. So we get to do a lot of different things. The crane that we have in the lab that I showed you just a second ago can lift up to 10,000 pounds. And so we, like I said, we did get to do some big stuff, but beyond just letting students see what we do in the lab, we actually get to also have some projects where they build them themselves. We have two of those projects, one of which is a reinforced concrete frame. So the students build the frame themselves here in the lab. We also have a steel plate girder design that students build here in the lab, which Kelsey's going to tell you a little bit about here in a second when I turn it over to her. So I wanted to share a couple of pictures with you here to show you what this is like in a classroom. All right, so this is a snapshot of the junior year within the civil engineering curriculum. And I'm not going to touch on every one of these classes, just a couple of them. There's two particular classes that relate to structural engineering. And the first one is structural analysis, which you take during your fall semester of your junior year. And during that class, rather than just having typical lectures in class, we do a lot of hands-on things as well in the classroom. And so here's a picture of the students learning how to calculate deflections on a beam. So you can see there's some equations and stuff on the screens behind them, but then they also get a chance to actually physically do this themselves. And so they're standing on there. We know how much each student weighs. There's scales under the styrofoam that you see there, and students get a chance to calculate what those reactions should be, what those deflections should be, and then they get a chance to actually measure those live. And then jumping over to spring semester, we have the Introduction to Structural Design course. And this is the one where we get to do some of the larger testing, where we test the big concrete beams, the big steel beams. And so here's a picture from this past spring when we were testing one of those concrete beams. And so this particular beam was 19 feet long, and we're pushing down right in the center there with that yellow hydraulic actuator. And this beam took about 35,000 pounds, if I remember correctly, before it broke. And you can kind of see the little vertical lines there that we drew with Sharpies. Those are all cracks in the concrete. And so the concrete is held together by the rebar. It doesn't keep it from cracking, but it keeps it from coming apart. And then a couple of days later, we did a beam that was designed differently and failed differently. And it took about 80,000 pounds to break. So we get to do some big stuff. Students will work through some videos and some quizzes before they come to class. Then they will predict how much they think the beams will take, and then we test them to find out if we were right. And then in the lab component, and one thing you'll see about our curriculum is we have a lab with just about every civil engineering course that we have. And the lab component of that course has those two projects that I mentioned earlier, the reinforced concrete frame and the steel plate girder. And so this is the steel plate girder that we do, and this was actually Kelsey's beam. She can tell you all about that here in a second. But the beam is about 7.5 feet long, and students get a chance to weld those beams. We have some welding stations set up for the students. We teach you just enough to get you through this project. And so you can see here that they had some pretty good welds. They also had a little fun with it and welded their initials into the beam. But this particular beam took about, I think it's about 13,000 pounds pulling down on it before it actually failed. And you can see it buckling out of the page. So the beam itself weighs about 80 pounds, but it took about 13,000 pounds before it actually failed. And so with that, I'm going to let Kelsey tell you a little bit about her experience as a student going through a lot of those experiences.
Okay, hi, good morning, everyone. My name is Kelsey Musa. I'm from Belize. I'm a graduate student doing the MS program in civil engineering, but I also received my undergraduate degree here at SLU. I'm currently working on some research in the structures lab with Dr. Carroll. And I know when we think about civil engineering, we kind of we instantly think about things like concrete and steel. But here at SLU, we really try to incorporate additional things such as fiberglass or FRP and even 3D printing. There's also actually an upper level course that you can take that kind of gives you a little bit of FRP, wood, and masonry if you're interested in alternative design. So I just kind of wanted to give you guys a little information about why I chose to attend SLU. And it was mainly because of how the undergraduate program is structured. I really like that it exposes you to various civil engineering subdisciplines. So you really kind of get to feel out which one you're most interested in. I also really like that there's a lot of females in the program. Fun fact, this year, civil engineering has the most female students by major in parts. So I think that's really cool because I'm all for women in engineering. There are also various research opportunities, and undergraduate students get to work in labs, which isn't always the case at some other universities. Lastly, I just wanted to highlight that we do actually get to have a lot of hands-on experience in the program, which is super cool. As Dr. Carl mentioned, some of the projects that you get to make are a concrete bowling ball, a reinforced concrete beam, and a steel plate girder. As Dr. Carl showed you guys, working on our steel girder was pretty fun. You get to design it yourself and weld the pieces together. We also had a little bit of fun with it. We welded our initials into it. So that was cool. Testing it was also really interesting to see. As he showed you, ours actually like buckled out of plane and popped back into place. It made a really loud sound, and I'm pretty sure like our entire group jumped when we heard it, but stuff like that is really cool to see. So I hope that gives you guys a little idea of what you can expect if you decide to come to SLU. It's really fun. It's really interesting. And yeah, I think I'll hand it back over to Amy. Thank you all for your attention.
Thank you, Kelsey. I'm so excited for students to meet you because I just think you have such an interesting perspective and you've done so much with this program and are continuing to continue on in your master's program. So now we'll take some questions. Feel free to submit some to the Q&A feature in Zoom or add them to the comment section in Facebook. We have one question already about welding the beams and testing the beams. So when testing is happening, where do students sit? What kind of protective equipment are you using? What kind of safety measures are implemented in the lab space?
So when we're testing the beams, we actually do have to wear like safety glasses, and we have to stand a little distance from the beam, but it's not that far. Like you're still very up close to the beam. And even though it like pops out of place, you know, things aren't like exploding. You're not gonna get hurt, but Dr. Carl makes sure that you're close enough to see it and really get a feel of what's happening, but far enough to make sure that you don't get hurt.
So I'll add to that just a little bit here. So students are always required to wear safety glasses when they're in the lab. Depending on what we're doing, they're also required to wear hard hats. If students are working in the lab, they're required to wear steel toe boots. Students are only allowed to use specific equipment that they've been trained on. So for example, only graduate students that have been trained are allowed to use the crane. They have to go through training videos, and they have to go through a series of tests with me to make sure they understand how to do that. Same thing goes with table saws, the welding equipment. So anytime the students are welding, the lab technician is around to always help with them. I'll show you some of the safety features actually with the welding. Then I'll touch a little bit more on testing. So for the welding, this is a smaller version. We usually have more tables out, but of the welding equipment. And so this one right here, as you can see under the table, is to collect the fumes. And so what they do is they position this little hose near where they're welding, which is where one of my grad students is working on this recently, and they will suck all the fumes up so that you're not having to breathe any of that. And then also, we have some fun stuff we got a little creative with for SLU. So we also have plenty of welding safety equipment that our students can use. And so I had a little fun with this and did a little marketing on our welding helmets at the Billiken. So they have that. They also have welding gloves that they can use. And then we have welding jackets that the students wear. So we take every precaution that we can to make sure that they're doing everything safely. And then when it comes to testing, the students are not allowed to be testing themselves without me around. I mean, they actually get to physically test it themselves, but I have to be here with them. So I'll show you a little bit about how that works. The steel beams they test are overly designed with the connections. So you can see up here that there are 3 bolts that are holding that together on each end. And then the testing mechanism is also over designed to ensure that nothing is going to fail from there. And so when the students are pulling down on the beam, we have a 99% idea of how the beam is going to fail. And then when the students are around it, like I said, they have to wear safety glasses, appropriate safety equipment, and they're not close enough or in any danger when they're testing those beams. And the same thing goes for when we're testing the large scale reinforced concrete beams in class. Contrary to what you may think, they don't explode. The way they're designed, they're not going to explode. And so it's actually kind of a little bit of a softer failure, and everything's going to go down. And so students are not within probably 10 feet or so of the beams, and they're all wearing safety glasses when we're doing that. We actually have yellow lines painted on the floor here. And so if you're within the yellow lines, you also have to have hard hat and steel toe boots on when you're doing things. So I hope that answers your question.
That was excellent. Yes. Yeah, I've been around when you've been testing the concrete beams, and it is a slow testing process, probably maybe 30 minutes. And yes, the end failure you're looking for is really more of a crumble, right? Just
in most cases, yeah.
Not too exciting, but very interesting all the same. So we've been talking about welding and pouring concrete and all of this hands-on, everything that goes on specifically for this lab space, but also within the program. Do students that enter the program need to have those skills already, or is everything taught on site?
We generally will teach students everything they need to know with regard to that. So the students that come into class, there's an online safety program that we use through SLU for them to go through those trainings. And then when it comes to welding, it's not a skill that you're going to use as a civil engineer once you get out of school, but it's something that I think is important for students to experience at least once, during their time in school. And so we teach you enough to get through that project. If you work on the steel bridge, you're going to do a little bit more with that. And surprisingly, I have yet to have a student say, I don't want to learn how to weld. Everybody actually gets pretty excited about that. I know Kelsey's group did.
We did.
That sounds great. We have a question. How long does it take to make one beam? So one concrete beam and one steel beam?
So the concrete beams are actually pretty intense to make. Let's see if I can show you some examples here of what's inside of them. So luckily I still have these cut up. So this is the inside of a concrete beam. All right, so let me get a better view here. So you can see all the steel that's in there. This one actually has a little bit more in it. So there was more rebar in the bottom. And so what we have to do is we have to form that up. And we have to form it up and we have to tie all of that rebar in place. And so the grad students will typically come in and they will assemble all the rebar cages and they will tie all the rebar in place so that it doesn't move. And then we actually bring a concrete truck right here to the garage door. And we have a concrete bucket, which is right here. So here is our large concrete bucket, which will take about 9 cubic feet of concrete, so a third of a cubic yard. And we hook that bucket to the crane and we wheel the crane and the bucket up to the garage door and we dump concrete in the bucket. And then we take that bucket and we run it back and forth with the crane to fill up the concrete beams. So it's a pretty involved process. And then those beams will take actually about 4 weeks to reach their full strength. The steel beams, the ones that we test like this, are pre-made from a steel mill. And so those come to us cut to length that we order. So those literally come on a truck. We take a forklift, we pull them off, pull them into the beam. We drill holes in them where we need them, and then we can test them. The beams that Kelsey and the other students have made in class, I would say it probably takes, given that there's a learning curve that you got to overcome there, I would say it takes 2 or 3 weeks to do the welding. The design process is done ahead of time, and then they tell me what size pieces they need, and then we pre-order those already cut. And then they just have to do the welding, which usually goes fairly quick.
Awesome, thank you. Kelsey, I'm going to turn it to you. Would you tell us just a little bit more about what drew you to civil engineering specifically, and what your goals are for your career after?
So I think I'm really interested in civil engineering, mainly because I just love knowing that something I design or create can really be beneficial to a lot of other people. And my goals are, I hope to gain some work experience after I graduate with my master's degree. And eventually I do want to move back home. As I mentioned earlier, I'm from Belize. I'd like to probably move back and contribute to the development of my country. And after I gain some experience, maybe, open my own design firm one of these days.
That sounds awesome. Dr. Carroll, can you talk a little bit more about, from the civil engineering program, what are some of the different career paths available, not just in structural engineering, but within the entire field itself?
Sorry, I was muted. So we have a really good relationship with industry within the St. Louis region that goes beyond just structural engineering. That includes all of the other subdisciplines. We have several students that go into the construction field. We have a lot that go into structures. We have several that go into the other subdisciplines as well, water resources and environmental, which I know you'll hear more about in another webinar down the road. But it's not just that. With a degree in civil engineering, you could also work for companies like Boeing. So from a structural engineering standpoint, Boeing likes civil engineering students that have a structures background to work on aircraft design, things like that. One of our adjuncts actually works at Boeing as a civil engineer. And then you also have the opportunities to go into grad school, right? Obviously, we would love to have every one of our students stay here for grad school at SLU, but we also love it when they have the opportunity to go to other schools and experience other programs as well for grad school. And so we've had a couple, I think 2 right now, that are one's at Penn State, and she's doing 3D printing of concrete, and so we're super excited for them to have those opportunities as well. And then, there's other things you could do, like Engineers Without Borders, for example. So there's nonprofits that you could work for as well. So it really depends on what you want to do and which direction you want your career to go.
It sounds like it's a degree that's very mendable and can be tailored to any student's particular interests.
Absolutely. And that's one thing in the curriculum too that's nice about ours is it's very flexible. So for example, I have a couple of freshmen right now that are planning to go on to do something in architecture after getting a civil engineering degree. And so we're tailoring their experience in undergrad to also include a minor in art, so that they have the prerequisites they need to go on for a master's degree in architecture later on.
Add in some creative aspects too. I love that. So we get questions a lot from high school students. Maybe this is the first time that they've considered civil engineering or really learned more about it and all the different opportunities with it. Dr. Carroll, what are some recommendations you have for high school students who think that they might be interested in this career path? What can they do now to prepare?
So I would say, first of all, take advantage of opportunities like this. Learn as much as you can about it. If you're visiting schools, make sure you learn as much about their programs and what their classes are like. Right now, given that we have Zoom sessions in most of our classes, I know I would be happy if anybody wanted to kind of sit in on one of our classes via Zoom and kind of check that out. But also I would encourage you to visit and talk to other students. That's one thing here that I would say we do a pretty good job of is having our students interact with potential students so they can get the student perspective and not just, a professor's perspective. Other than that, I would say, in high school, if you're junior, senior year, take as much math as you can. We care more about you being prepared mathematically coming into engineering than whether you can use AutoCAD. I mean, AutoCAD and those skills are great, but we're going to teach you what you need to know when you get here. But the more math you can get out of the way, the more further along you're going to be when you come in. And it also opens up other opportunities for you to get minors, double majors, and everything like that because you have extra credits you can take then.
Excellent. And speaking of that student perspective, Kelsey, do you have advice for any high school students that might be preparing for an engineering degree or looking at it?
Well, just kind of building more off of what Dr. Carroll said, my advice would probably just be to really get in the habit of putting yourself out there, getting to know people, not being scared to ask questions. Also, even if it may not seem like it, professors really pay attention to your attitude and the quality of work that you're putting out. So most times these students are the ones that these professors want working in their research labs.
Yeah, I would follow up on what Kelsey just said. I don't think a lot of students realize how much we pay attention in class. We're looking at who is there, who has a good work ethic, who's doing well on our exams. And that's really the students that we pursue and want to work in our lab, the ones that we know are going to have that work ethic.
Yeah, so that attitude can make up for somebody like me who might not have the greatest skill set in math and math related concepts, but what would you say to a student that was interested but felt that they weren't super strong in math, like you said?
I think that work ethic goes a long way. I feel like I was one of those students. I didn't learn how to study until I was, well into college. And the work ethic plays a huge part in it, whether you're a current student or whether you're going into the workforce, right? If you have a 4.0, that's fantastic. But what have you done with that 4.0? That's something that I look at, as a professor looking to hire grad students. That's something that employers are going to look at as well. A lot of professors employers would be fine with a student with a 3.3 GPA that has a fantastic work ethic, and has done a lot of extracurricular activities to gain experience and had internships, over someone that has a 4.0 and didn't do internships or didn't get involved and didn't do anything extracurricular.
It just sounds like excellent advice all around for any profession that someone might be interested in. We have time for just one more question. So Dr. Carroll showed a picture of our Billiken logo on the welding mask, I guess. So Kelsey, what's your favorite thing about being a Billiken, being a student at SLU?
My favorite thing about being a Billiken is knowing that my education will allow me to better myself in addition to helping others around me. I also like that being a Billiken has given me the necessary tools that I need to go out and change the world if that's what I want to do.
Excellent, excellent. Well, thank you, Dr. Carroll and Kelsey, both of you for being here today, giving us a virtual tour of the Structures Lab. If any of our viewers would like to learn more about the engineering programs, including civil engineering at SLU, please visit slu.edu/parks. Also, please feel free to reach out to us at parksevents@slu.edu to get further connected with us. As Dr. Carroll said, with perhaps dropping in on a virtual class, we can definitely help set that up if you send us an email. So we hope that everyone will join us next week again in this webinar space on Thursday, September 24th at 12 p.m. And we will be heading just next door to the Structures Lab to visit the Wind Tunnel Lab. So thanks again and have a great rest of your day.